Hey guys, this is Dave here. Had a lot of questions and comments about the gap analysis I posted on LinkedIn, and I figured I'd go through uh, my methodology for doing the gap analysis, and if it's useful to you guys, fine. If not, use it or don't use it. Anyway, there's 5 basic charts that I use. I use an integration matrix. I use a spec analysis. I do a drawing analysis. And then for presentation, I generally use some type of bubble chart. And I've got 2. One is a basic bubble chart, and the other one is an intelligent bubble chart. So for this first one, this is the integration matrix. And in this case, it was for Kuala Lumpur International Airport. You can see the complexity of this one. There were some 158 separate locations, buildings, etc. This isn't the technical rooms. This is the different buildings that were located on KLIA. So step number 1 is you got to find out where all your stuff goes. Number 2 is you have an interface list. And so here what you have is your airfield ground lighting to a BMS. The connection is through an information broker, etc. So you've got to go through all of the different specs and drawings to find out these high-level connections, whether if it's a network or an information broker only. Some go to the operational database. It's assumed that if you've got an IB connection, that you also have a network connection. Okay, so for all of these systems, you can see the corresponding system that they were going to be connected to. And in this case, in KLIA, there were 193 unique interfaces. So to take this chart a step further on the integration matrix, we just do a simple XY. So you've got your AODB, Airport Management Database, your FIDS to FIDS. So where they intersect themselves, we put a blank. So in this case, the AODB has a data interface to the information broker. It's got a database to the airfield management database. It's got a data interface to the FIDS. It's got a data interface to the AIMS view. And so here's across the top is the same list that we have across the bottom, and quite a few interfaces. I can't remember the exact number. Let's count them. So we had in KLIA 149 unique systems integration systems. So your next step in preparing your integration study is to prepare this type of matrix, and it requires reading every spec. So sometimes these specs are only located in your SAS or ELV. Sometimes they're in your BMS, they're the baggage system, or in this case the fixed ground power, etc. So all of these systems, you have to go through your unique specifications and whatnot to read them, understand where they have a data interface. So in this case, just use the quarantine line. It's got a data interface to the FIDS. Okay, so obviously quarantine wants to know when the flights are arriving and if there's any animals and whatnot on it that needs to look at, or if maybe it's coming from a country where people have some kind of outbreak of some type of infection or whatnot. Now in this case, for that cell, you would look at the FIDS database specification and drawing, and you'd look at the quarantine. So in this case, if the quarantine didn't have an interface to the FIDS, what I normally do is I would color code that cell format the cell. I would change that D to a red color. And that tells me I have a problem. Now, I've eliminated all the colors on this chart because I didn't want to show all the problems with the specs. And the spec problem normally comes about because the designer, engineer, or whatnot, they don't do all the specs by one person. They're scattered across several design organizations and whatnot. And they focus on writing the specs of what they're familiar with. Okay? So the guy writing the immigration computer spec may not be a FIDS guy. So unless the FIDS designer and the immigration designer get together and make sure that their specifications are lined up, you're going to have a gap. And by color coding these, you're going to find out where all your gaps are. So that's a very simplified integration matrix. Close that guy. Close it. I'm not going to save it. So the next one I use is basically a study. Okay, and this one refers to the specs. So that's this guy here. So we make him big. And so what I do on this guy is go through all the specifications. And sometimes you'll find that your SAS ELV specs are associated with other systems. In this case, we have the elevator spec. And within the elevator spec, 142100, it references all of these guys, all the way down till the escalators. So in this case, we've got about 21 interfaces that have been identified. So what you do is you say in 142.100, is it lined up with 13520? Okay, and if it is, leave it alone. It's complied. So you've got a match between the elevators and these. These are general type specs. So here they have an interface somehow between the elevator and the moving walkways. So it's referenced, but we don't have any requirements for that. So while you know you have an interface, it's something that has to be defined later. So if you're just starting your job, this may be a topic for a site clarification request. And again, we've got an interface to 27100, which is your telecommunications infrastructure. So in here it's telling you you've got Cat5 RJ45s for elevator monitoring. Well, that's fine. You've got an interface, but you don't know really where in your elevator shaft or in the elevator itself, whether it's at the bottom of the shaft, top of the shaft, you don't know where you're going to put that jack. So that gets color coded. Need to know where to put the puppy so you can get your Cat5. This is an old spec because it's from Kuala Lumpur. But anyway, you get the point. So this requires going through every single specification that might or could have an interface to ELV, SAS, some type of communications interface. Even the waste chutes, people may not even think there's some kind of interface, but there's security access control interface. So these guys are highlighted so you know, where do I put it? So here you go into fire suppression, all of these. Okay, again, I've hidden some of the bits and pieces because I don't want to show everything on that particular airport. Now you're going to do testing, adjusting, and balancing specification. So here you have a computer room air conditioning system. But unless you know all the computers and all their servers and disks and all the equipment and where the room is, you don't know how to even size that computer room air conditioner. So he should be asking the SAS ELV guys, how big is it? How much cooling power do I need? So it's referenced. Same with the fire alarm. What kind of fire alarm? Is it FM 200? Is you going to sprinkle it? So again, you have those types of interfaces that need clarification. Same with the BMS to the FIDS. So here you've got a requirement to interface to the FIDS. As stated, in real time the FIDS shall send information via the information broker to the BMS. Wow, that's a pretty little complicated little system, because a lot of FIDS systems don't have that capability because they're two different types of IT systems. But anyway, you get the point here. This takes going through every single specification to find out where all your gaps are and where you need to raise SCRs or get further definition. Because all of these will require some form of interface control document or interface design document, or whatever you want to call it. You basically have to define that interface. As you can see, and if I sorted how many red lines I have in here, these are all going to be subject to either an SCR or some type of workshop. So out of the 1,117 line items, even if it's 20%, that's a couple hundred of interfaces that need to be further defined. Okay? So that's your interface elements based on the specification. The next interface is a gap analysis with drawings. Sometimes the drawings give further clarification that isn't necessarily in the specification, but you have to read the drawings and the specs. So here, what we do, and this is just the PTB, we have a bunch of drawings. Let me make it a little bit bigger. So we have a bunch of drawings here, maybe too big. So drawing level 0, drawing sheet number 1, and here's all your IT systems. So not knowing what's on level 1, a drawing not required. Well, that's kind of interesting if you think about a fire alarm system, because normally a passenger terminal building, the entire building has to have a fire alarm. So these drawings here may need clarification, whether it's a structural void or not. You still need some type of sensor or something. Okay, again, I've hidden some of the problems, but those were definitely problems. And you can see on this sheet 13, there's something about the FIDS. So we have a drawing. So again, you go through all of these line items, every single drawing, to figure out if you've got all the proper drawings done. Sometimes you may have a drawing, but it may be on the list, but you haven't received it. So in this case, we're missing a layout drawing. For level 3, sheet 75, we don't have any SACs here and no FIDS. Well, that tells me that that line item right here probably has something to do with check-in. Okay, and you can go across all of your systems. Okay, again, this is a very simplified look with a significant amount of the missing drawings done. Here's your CCTV. So here you have a SACS and a CCTV, and you're missing a drawing. So how's that SACS going to interface to the CCTV? Does the CCTV look at a door? Does it look at a hallway? And whatnot. So that's your gap analysis based on drawings. And again, this should be every single drawing in there. And it could be, and it also should include the architectural drawings, which I've hidden on this one. These are just the drawings associated with these systems. These systems also have to be correlated to the architectural drawings. So that's your gap analysis on the drawings. The next kind of a chart, which is kind of useful, because if you're a programmer and coder, you like to know exactly where all of your interfaces are going. Excuse me. So in this case, we've taken every single system that you saw in the previous list, Actually, this was a tender for, I think, Jeddah Airport. So what we did with this guy, and I'll make it a little bit bigger, this had two functions. Because it was a tender document, what we did here is, we'll take the nice simple one, we have a land spec, baggage reconciliation system, that's got a link into the baggage reconciliation system here. Now if you look on the left hand side, I put these pictures in here because sometimes non-technical or management people, or maybe people just don't understand what these systems are, because we use a lot of acronyms. So if they can see the graphic image of the baggage reconciliation system linked into the baggage handling system, you can see it's got an interface. And all of these systems go through the local area network in the red colors. Okay, so here's your common use self-service system linked into the LAN. She's also going across over here into the AODB and IB. The interesting point of this type of drawing is every one of these lines has to have a data definition or an interface control document. How does the public address system connect to the AODB? What's the purpose? Is it to get flight information or whatnot? So this guy has to talk to this guy via the local area network. So you're going to need IP addresses, you're going to need VLAN addresses, etc. So this kind of little chart, here's your storage area network. So this could possibly be used to size your computer room air conditioning system. So anyway, as you go through this, you'll see different types of systems. Preconditioned air, boarding bridges, again, fire alarm systems, your building management systems, your electrical related systems, and here we have SCADA and EPMS, lighting control. A lot of times these are missed, but they've got to get into these systems. So how are they going to get there? It's going to take this line, somehow has got to get here. Is it going to be a direct connection or what? And if it is, how's it going to get from here to the LAN? So that means there could be a gap. So again, here now we have all of our conveying systems, security systems across the bottom. There's a security command and control center. Sometimes people forget that, especially who's going to pay for the equipment. You can tell this chart's a bit dated because we don't have access control like this anymore, but it gets the point across. So here is a little simplified drawing of how people go into the building, get processed through the building, customs, immigration, out, security clearing process, hold baggage screening and whatnot, and then onto the airplane. So sometimes you can use this type of drawing as a nice way to explain your system to your managers and whatnot, especially if there's gaps. And you can do a simple bubble chart of that system if you like. Again, this is just going to be for show purposes if you're making a presentation. This is a simplified way of looking at the same systems into the core, which is your local area network, your collapsed backbone with your information broker, AODB, SAN storage, and whatnot. Okay? So that's your high-level bubble, no intelligence, but all the specs are identified so you know where to find each and every one of these interfaces if you don't want to have it automated. So we're going to close that guy out. And here's the gorilla, really. So this guy is the final chart I use, especially if you've got a bunch of IT people. Because in this hospital system we did for Al Mafraq, what we did is it was very highly integrated. And you can imagine life safety, etc., especially with like pharmacy. So for this one, what we did, let me zoom in a bit. You can see every system is connected to the main servers. So this converged data network here will have all of these systems in a data center. So this required a data center build. So zoom in a bit. And so what we did here is, if we look at your pharmacy interface, it's a little bit hard to read, but basically they had an automated pharmacy system. So here, if you mouse over, you can see the exact requirements of that interface. And in this case, it just said IT connectivity requirements. It didn't tell you what they were. And it had to be HL7 compatible, which is the protocol used probably 8 or 9 years ago with hospital systems. And it says it has to have the ability to connect to the hospital information system using TCP/IP or IEEE 802. So, meaning they didn't know what they wanted to do. So yeah, it has the ability, but do you want it to do it? Okay, so this type of bubble is very useful, especially when you have a really lot of interfaces identified. Some have more, some have less. And you can see all those operational requirements they put there for this system here, which was your cabinet detection system, because they don't want people stealing their drugs. And again, here we have your laboratory equipment. So again, you see a very simple interface. All of these had to be defined in a interface control document or interface definition system. All just basic interfaces. Excuse me. And you also had interfaces to the building management system. So here we had the building management system was actually monitoring the gas, you know, the oxygen and whatnot, because people go to hospital, they need oxygen. So you can see the complexity associated with that. Tremendous visual system, because new systems today, they don't really spend a lot of time developing x-rays. They're real time, so the patient doesn't have to sit on the operating table for 30 minutes waiting for your x-ray to come out. They're actually scanned and then displayed on large monitors where the surgeon can see what's happening. So again, this is the last bubble, and this bubble is fundamentally used for primarily IT people, but it's nice if you're making a presentation to your project director or your engineering director or the client, showing him where all the interfaces are missing. Again, what is HL7 compatible? You know, like this one is just based on standards. So you can see all of the little interfaces also. Let me just zoom in on that one real quick. So when you have these interfaces here, these medical equipment interfaces, and there's 96 interface types, talking to these 1, 2, 3, 4, 5 different systems via the network. So every one of those interfaces needs an interface design document done, otherwise you won't be able to test it. And obviously for a hospital environment, not that airports aren't important, but in a hospital environment you have very serious life safety matters. Anyway, I hope you enjoyed this short video, and again, if you like it, if you want something for your company, I do it part-time here in the Philippines. I don't travel anymore. I just do it here at the beach, and at a reasonable cost. So enjoy, try to like it. Bye.